Good afternoon, good morning, good evening. Thank you very much for joining us this morning on today's Optics.org hosted webinar with the team from ScannerMAX. Good morning, gentlemen.
Morning, Rob.
Hello, Rob.
Okay. First of all, thank you everyone that's attending us on today's webinar. A few simple house rules just to run through. You'll find a chat box at the bottom of your little desktop device when you logged in. If you have any questions for either Ryan or William, you can pop them into those chat box, and then at the end of the presentation, there'll be a Q&A, and we will try and get through as many of those questions as possible. If for any reason we don't answer your question, don't worry, someone from ScannerMAX will get back to you directly and follow up in due course. Also, I wanted to let you know this is going to be recorded, so if you miss any of this presentation or you want to watch it again or pass it on to your colleagues, then the video will be available to download from the optics.org website in about 24 hours or so. What I'd like to do first of all then, of course, is introduce two of our presenters. I'm here with William Benner, who's the 5-time best-selling author and comes from a household where innovation was at the forefront. His father worked on the NASA mission control computers that put man on the moon during the Apollo space program. And he's been granted numerous patents and awards and has received personal letters of commendation from the President of the United States and the Governor of the state of Florida. So that's a pretty good start you've got going on there, William. So, for that, also, we are joined by Ryan Smith, who joined ScannerMAX in 2014 after studying mechanical engineering at the University of Central Florida. He has worked under William Benner during this time, learning the technical details of optical scanning whilst assisting in the development of the ScannerMAX product line. Much of his time is spent assisting customers implement ScannerMAX products into their product lines and steering development efforts based on market trends. So again, thank you very much for joining us today, gentlemen. What I'm going to do is pass over the speaking roles to William to start with. I will turn off my mic so I don't interrupt you in any way, shape or form, and we can take it over from there.
Oh, great. Well, thanks, Rob. Thanks for the gracious introduction. You go to the next slide. All right. Well, one of the things I think that would be important for people to understand is who is this company, Pangolin Laser Systems, and the ScannerMAX division. Well, Pangolin Laser Systems, you may know of. If you don't know us by name, you certainly know of us by what we do. We are the largest provider of software and hardware that's used in the creation and performance of laser light shows. We're talking about the light shows that happen at the theme parks, Disney, SeaWorld, Universal Studio, all of the sporting events that happens, the NHL, the NFL, even the Super Bowl halftime show, all the rock concerts that happen, and movie special effects, and even your local pubs and clubs. Anywhere you see a laser show, chances are that our hardware and software is involved with that. So that's really where we started. We started in 1986, almost 40 years ago. And we have a laser entertainment division. That's what I just talked about. We also make a laser semiconductor product called Laser, which makes laser diodes last longer. And finally, what we talk about today is the ScannerMAX division. This is a division that makes laser scanners. Next slide, Rob. Yeah, so the title of this webinar is Learn Laser Scanners, the must-know technology. And so the reason why I chose that title is because I wrote this book, Laser Scanners. You can kind of see a graphical depiction on the screen. This stuff is not taught in schools. They teach you in optics, they teach you lenses and lasers, and maybe if you're lucky, you learn about spatial light modulator, but no class ever talks about laser scanners. And laser scanners are the thing that makes a laser useful. A laser produces a beam of light. Congratulations, beam of light. And what are you going to do with it, right? So in order for the beam of light to be useful and to do useful work, in most cases, it must be moved or scanned. And that's what we make here at ScannerMAX division of Pangolin. And yet we make a product that people are not learning about. And so I wrote this book to help people to learn about laser scanners. Now, this book covers all types of laser scanners. We're talking about acousto-optic, electro-optic, MEMS, polygon scanners, and resonance scanners, and all kinds of scanners. Today, in this presentation, we're going to be talking about a single type of scanner. It's called a galvanometer scanner. But if you want to learn about the variety of laser scanners, you can read my book. It's available on Amazon, and everybody who's attending this webinar will get a free access to the PDF version. So you'll be able to get that and really learn laser scanners. So that's what we promised. That's what we're going to deliver. So what's inside a laser projector? Remember, this is where we started. We started in laser entertainment. What's inside a laser projector? Well, a laser projector is really pretty simple. You got lasers, one or more of them. In this case, what we're seeing here is red, green, and blue sources, which we combine this into a single, what we call white beam. And then there's power supplies to operate the lasers and control electronics. And then there are these galvo scanners here on the lower right-hand corner. These are the things that move the beam and make a laser light show out of the laser. And so the laser scanners are really the heart of the projector. It's the engine. It's the thing that makes, like I say, it really does useful work with the laser. Next slide, Rob. Yeah, and so as I mentioned, there are numerous types of laser scanners. The electro-optic. If you're thinking about how you're going to move a light beam, you can move a light beam through reflection, and that's what we do. We reflect the beam off of a mirror. You can do it off of refraction, and that's what electro-optic scanners do, or you could do something called diffraction, and that's what acousto-optic scanners do. So these are the three types of ways that you can possibly move a light beam. What we do with the galvo scanner is reflect the beam, and when you reflect the beam off a mirror, there are many benefits, and so we'll talk about those benefits here in a second. But the actual characteristics of a galvo scanner. First of all, what is a galvo scanner? Is a mirror that you put on the end of a motor. Is just think about it as mirror on motor. We have a very precise position sensor in the back. We can very precisely position that mirror. And so a galvo scanner is motor, mirror, and position sensor, and some way of controlling this. So the scan angles are very wide. That's one of the benefits of this type of scanner. You can get very wide scanner, in our case, over 110 degrees. They're reasonably priced in small quantities. This presentation is a little bit dated, but the small quantities you can get a scanner, and very high quantities you can get just the scanner itself for about $125. In high quantities, or in quantity one, a single system would be about $2,500. And with this type of scanner, any type of scanning is possible. This is not true with the other types of scanners. Some, like resonance scanner, it's always a sine wave. With a polygon scanner, it's always a sawtooth. With a galvo scanner, you can make any kind of scanning possible, whether it's point and hold, or vector scanning where you're drawing an outline, or raster scanning. Any type of scanning is possible with a galvo scanner. And the applications are, of course, laser light show. That's how we got into laser scanning, but also laser marking and cutting, 3D printers, self-driving cars, medical microscopes, and so many other things. Next slide, Rob. So as I was mentioning, what we do here with the galvo scanner is we reflect the beam off of a mirror. And here are the benefits of reflecting the beam off the mirror. Well, since it's a mirror, you have very high throughput. Almost 100% of the light that hits the mirror gets reflected off the mirror. So you have very high throughput. That's one of the benefits. Another benefit is that you have a wide scan angle, so you can move the mirror. Another benefit is it's polychromatic. In other words, that if you have red, green, and blue like we do, or infrared and visible as some people do, those beams can be reflected, and not only can they be scanned, but they can be scanned by the same amount at the same time. There's some types of scanners that, even though they're quote unquote polychromatic, you can scan the beam, the red scans not as wide as the blue, right? So there's a separation there. So again, by moving a mirror, there's just a lot of benefits that come with this. And there's another benefit, which is a bidirectional scan path. So for example, the laser beam can hit the mirror, go out to the target, and then the target can become illuminated, and that illumination can come right back through the mirror and back into the system. This bidirectional nature is used in certain microscopes and, of course, LiDAR that's used in vehicles. So these are very big benefits. Now, the drawback of a galvo scanner or a scanner that moves a mirror is we're actually moving the mirror. The mirror has a certain amount of weight. It has a certain amount of flexibility. And so this presents a limitation in how fast that you can scan the beam. So it's almost all good news. The only bad news is you're literally physically moving something, and there are any limits to this scanning technology have to do with the fact that you're moving something. Next slide, Rob. Yeah, so this is one example of a scanner. I have it in my hand. Here's another example of a scanner. It's just to give you an idea of how big and small these become. This is the tip of my finger. This is the scanner. The whole scanner is the size of the tip of my finger. So it could be very small. And this is the biggest one we make. It's not quite the size of my fist, but so this is about the size and shape that we're talking about. And what you see is a connector on the back, right? And so what it means is this connector cannot be connected directly to your computer or your embedded system. There has to be some way, some kind of interface in between your computer embedded system and the scanner. And these interfaces are called servo drivers. And we have two kinds of servo drivers here at Pangolin. One of them is a digital servo driver. As you can see here, it's what we call the Mach DSP. It has a 32-bit floating point DSP. And the benefits of this is it's digital. It's kind of the modern thing we're all doing. It's computer controlled. And the computer can connect up to this, and we have tools that are built into the servo driver that we used to have to use separately. Tools like an oscilloscope. It's built right into our servo driver. Something called a dynamic signal analyzer, built right into even waveform generators are built into the servo driver. So you have these kind of benefits. It's all in one little box. Here's the size of my hand. Here is the servo driver. So you can kind of get an idea for the size and shape of this thing. And this thing will control two different types of two axes, two scanners at the same time, usually X and Y. Yeah, so that's the situation. It runs on anywhere between 15 and 24 volts. You do have to have what we call a split supply here. So that means plus and minus 15 to plus and minus 30 volts, really. And one of the benefits to this, as I say, all the benefits of modern stuff. It works like a computer. So if we need to, and from time to time we do for customer support reasons, we can access through remote desktop, we can access the servo driver and do remote tuning, remote access, remote troubleshooting, using this through all the benefits of this being digital. Next slide, Rob. Yeah, in addition to this, one of the things that we do, we have a limited number of analog servo drivers here at Pangolin. Mostly what we do in the realm of analog servo drivers is we help our customers to design in an analog servo driver. We help our customers do state space as well. So if our customer comes to us and they say, gosh, Bill, that thing is awfully big, you know, I got something, I have a size constraint or power constraint or something like that. Can you help us? Usually what we'll do is we will help them by supplying a schematic, supplying in some cases example code of how to make their own servo driver. And this is an example of something that we made for a customer, or worked with a customer to make, that they manufacture this as part of their system. So this is a whole servo driver, including the power amplifier. That power amplifier is the chip that you see right there. This is a PWM power amplifier. It runs at 1.2 megahertz, and the rest of it's analog. And this is more than just the servo driver. This also controls something else in their package. So this is just an example of how we work with customers to implement usually analog, but sometimes digital servo drivers within their system. Next slide, Rob. Yeah, so it's the common applications of laser scanners, and this is where I'll ask Ryan to speak up, because Ryan is really the kind of the first line of defense. When you pick up and dial 1-800 Pangolin and press 2 for ScannerMAX, you're going to get Ryan. And so I think Ryan would be the best person to talk about the different applications.
Yeah, as Bill was mentioning, we got our humble beginnings doing laser late show projections, and probably half of the laser show projectors out there are using one of our ScannerMAX lines of products, which we'll discuss in a little bit. But really, over the last couple of years, we've been getting a lot into the OCT laser scanning microscopes, biomedical type applications. They're able to realize the benefits of our stronger, cooler, faster scanners, which we'll get to the engineering details behind that here shortly, and also automotive LiDAR. To my knowledge, there's not many other galvo manufacturers delivering to this market. We've optimized some of the adhesives and the lubricants in the scanners to operate from -40°C beyond 100°C, which is what's required for automotive compliance. And then, of course, your typical laser or your laser scanner applications, laser marking, 3D printing is a new one. Template projection is a new interesting application where instead of having guys walk around when they're doing blueprinting of buildings and marking things with chalk lines and taking measurements all day long, they will make a laser projector type thing, which will project the layouts of pipes and conduit and where roof trusses and things like that are going to go onto a building, and then the laborers simply need to align the parts with the outline being projected on the wall or on the foundation rather than having to take measurements throughout the day. Dermatology type applications are common. 3D printing, as we mentioned, we have a variety of 3D printing companies using our scanners for SLA 3D printers. And then as Bill likes to mention, tiny self-driving cars with lasers.
Yeah.
Next slide, Rob.
Slide. Yeah. So as I mentioned here, one of the applications we get into is confocal microscopy, and there's a book called Principles and Applications of Confocal Microscopy by Neil Lagali, and I've misspelled his name here. It's Lagali. And so I've actually been in contact with Neil, and I have permission to use this picture out of his book. And so if you're interested in confocal microscopy, you should definitely get his book. It's really thick and is kind of the definitive work on this type of application. But this is an application where you have a laser which gets reflected off of the scanners and then goes onto, through some lenses and that sort of thing, onto your tissue. And then that tissue kind of fluoresces and gives a backscattering image that needs to come right back through the same laser scanner in the same area, and then go to a photomultiplier 2, which winds up doing the imaging. And so this is an example of where reflection type of scanning really comes in handy. Here he has, in the picture, it says scanning unit XY control. It's shown as a little thing. Really, that looks more like something like this. This is a lot bigger than what it is, but it's Ryan, do you have a small 2D version?
Yeah, right here.
Yeah, it'd be more like this. This is so the beam path in this picture isn't quite what it normally would be, but nevertheless, this idea is that you have light going in both directions, and this is where reflection type scanning and galvo scanning really has just a great home. So next slide. Yeah, and so as I mentioned, and as I've been holding up in my hand here, we've got one scanner here with one mirror, and there is a way in which you can put these things together where you have one of the scanners that's controlling horizontal motion and another scanner that's controlling vertical motion. You put these two together, and you can accomplish two-dimensional scanning. And you can use two-dimensional scanning with galvanometer scanners, as shown in this picture, or you can have other types of scanners where one of the scanners would be faster, could be a resonant or polygon, or even a Kusu or electro-optic scanning doing the horizontal scan, and you use the galvo for the vertical scan, and you get all the benefits of the galvo with the with high throughput, high reflectivity, and the fact that your vertical usually is slower than the horizontal, and so the drawbacks of a galvo scanner are not really important in that type of application. Next slide, Rob. Yeah, and so there's a term called raster, and what this means is covering an area. Basically, a laser produces a beam of light, and then you need to take that beam and cover the area. And one of the ways to do that covering of the area is what we call rastering, where you go line by line by line, and in a rectangular fashion, kind of scanning it both horizontally very quickly and vertically, moving this quickly scanning horizontal thing down and down and down, and then finally back up. This is what's called rastering. This is another example of a two-dimensional type of scanning arrangement. Next slide, Rob. Yeah, so I'll tell you about something that I've become passionate about, which is the history of galvanometers and scanning. In fact, to tell you exactly how far galvanometers goes back, I've got two books here on my desk, and these are not really the actual books. These are reprints, but this book here, Electrical Measurement and the Galvanometer by Thomas Dixon Lockwood, this book was made in 1890. So that's how long galvanometers have been around. The galvanometers, in fact, have been around almost as long as electricity, because when they figured out that there was some association between magnetism and electricity, and they built these elaborate things to try to measure electricity by suspending a mirror on wires between a magnetic field, and it would catch a beam of sunlight, and it would cast this beam and across the room, and by the deflection of the beam across the wall, you'd see. So galvanometers have been around for a super long time. In terms of the galvanometers that we use, the first galvanometer that was really practical that could be used in laser scanning, it was the G series, the moving iron galvanometer invented by Jean Montague and Pierre Brozens, who are both pictured in this picture here. In the early 70s, this is where the first real laser scanning galvanometer came out. Next slide, Rob. And this same guy, Jean Montague, came up with the moving magnet scanner in 1976. The patent was granted here in 1978, but it was 1976 that the moving magnet galvanometer was invented. It actually didn't go into production until 1992, because to make a practical moving magnet scanner, it takes something called supermagnets, neodymium iron boron magnets, which didn't come into really high productivity until 1992. So the first real moving magnet scanners came out in 1992, but nevertheless, we're talking about an invention here that is 49 years old. And the reason why I bring this up in this galvanometer history and why this is important is because Jean Montague invented the moving magnet scanner in 1976, and almost every other company that makes a laser scanner, a galvanometer scanner, makes them in the way that Jean Montague invented in 1976, what we call conventional galvanometers. I happen to have one here, one of our competitors' galvanometers here. It looks like this. Ours typically look a little bit different, but nevertheless, if it looks like this, it was invented in 1976. It's 49-year-old technology. Everybody else is selling 49-year-old technologies, but we are not. We have 3 different types of laser scanners that were developed starting in 2012. So we have really modern technology, and because of this, we have different, we have basically different outcomes for the customer. We can deliver a different result for customers than other galvo manufacturers can. Next slide, Rob. Yeah, and so why did we get into laser scanning? So like I said, we got our roots in laser light shows. And laser light shows are an area where if we can scan faster, we can scan more complex graphics. And one of the effects that we do with laser scanning is called audience scanning. We project laser beams directly into the audience. It's the most dramatic visual effect you can ever experience, where lasers are, one person described it as being in a swimming pool filled with light. You can reach out and touch the beams in the air. It's very dramatic. And the faster you can scan that beam, because it's scanning, it's in the people, so inevitably it's going to be scanning across your eye, and the faster you can scan it across the eye, the safer this effect is. It's called audience scanning. So we wanted faster scanning, and yet when we approached the laser scanner manufacturers, we said, hey, we want faster scanning. Here's how we think you should do it. We were ignored. The galvo technologies out there was stagnating. The kind of the legacy brands of the companies were not delivering. And when I made this slide, I said the legacy companies weren't delivering. Not only were they not delivering what we wanted, which was faster scannings, but during the COVID area, the legacy brand companies were not delivering literally at all. The supply chain crunch had hit them so hard that they couldn't deliver. One of the companies couldn't deliver for 2 years, and we delivered scanners the entire time. Next slide, Rob. Yeah, so being frustrated by the legacy scanner manufacturers, we created the ScannerMAX division. And so like I say, we've been manufacturing scanners since 2012. And now we have an extensive line of galvanometer scanners. And these scanners are designed into really demanding applications like vehicular, LiDAR, medical microscopes, and even space-based applications. We're the legacy brand company that used to deliver space-based lasers and stopped. They left the space industry high and dry. And so people started coming to us and said, hey, we need a scanner. Can you deliver? And ultimately we did. So next slide, Rob. Yeah, so let's talk about a little bit about what we call the ScannerMAX advantage. Go ahead, next slide, Rob. And so one of the things that we do is we form the rotor in a different way. It's a magnet. We have a stiffer shaft. The diameter of the shaft that we have going out ultimately attaches to the mirror is thicker. And the stiffness of the shaft goes as the fourth power of the diameter. So by just making the shaft go from 2 millimeters to 3 millimeters, we increase the stiffness by 2.5 times. Next slide, Rob. So another thing that we have done is we changed the internal motor of how the motor is formed. The picture on the left is if we were to slice open this competitor's galvo here, and we just slice it in this direction right here, what you'd see is a bunch of little wires surrounding a magnet. And so what happens is these, as you put power into the scanner, the wires heat up, and the wires heat up the magnet, and magnets hate heat. And so there's only one path out of there. It's along the circumference of the scanner. It's not a great way to remove heat. And so as a result, these scanners can tend to run hot. The picture on the right represents the stator of our Saturn series of scanners. And in fact, this is a side-by-side comparison, a computer model that I did, which represents these scanners doing literally exactly the same job. The rotor is the same diameter. In fact, in this case, the rotor has the same inertia, and yet what you can see here is in the temperature, the coils in our scanners remain cool because the path, that basically our coils are completely surrounded on 3 sides by metal, which can remove the heat, so the scanner runs cooler. So what we had before is a stronger rotor, and now we have a cooler motor. Next slide, Rob. And when you put these two things together, what we call the ScannerMAX formula, stronger plus cooler equals faster. And it's not only the rotor that's stronger, but we have a stronger magnetic field. We use a different type of magnet in our scanners. We have the way that we mount the mirror is stronger. The bearing materials, we use something called SPIE, which is the hardest stainless steel that you can, the finest samurai swords and the finest chef's knives are made of SPIE stainless steel. That's what we use in our bearings. And we also, the position feedback that we get, the position sensor is made in a different way, which gives us 4 times the signal to noise ratio as everything else. So it's a lot of things stronger. The motor runs cooler. When you put all this thing together, you get faster scanning. Next slide, Rob. So one of the things that's not mentioned in this presentation, it was mentioned in a previous version of the presentation, but exactly when I talk about the 3 different types of scanners that we produce, and one of the things I touched on a little bit here is the Saturn series, but I'll have Ryan talk about the other 2 types of scanners that we make, and I'll talk a little bit about the, which one's the Honda Civic and which one's the Cadillac and that sort of thing.
Yeah, so our Saturn series of scanners, which Bill showed in that kind of temperature map earlier, is our highest performing scanner for the most critical of applications, the fastest scanning, laser scanning microscopes, people who really need the cutting edge of performance. But I mean, realistically, not everybody needs the cutting edge. Sometimes people want to replace a legacy design and they need what we could call industry standard performance. And for that, we have our compact 506 scanner. That's kind of the middle row here. You can see on the far left and what I'm holding up, we put as small as 3mm beams or mirrors on this thing for 3mm beams for a 60-degree field of view. And what Bill was kind of just holding up over the last couple of minutes, that's the same scanner, the same physical scanner with a 20mm aperture mirror on it. Typically for reliability reasons, we only deliver the compact 506 for up to 10mm, but in certain cases, we can deliver larger mirrors when package size is performance. And this is a kind of good industry standard level scanner. It can be driven by our Mach DSP to deliver industry standard performance at a lower price point. And then the third one is our ARC series of scanners. The picture didn't make it in the slide, but it's designed for high volume, low cost manufacturing for people who want to make 20,000, 30,000, 250,000 devices a year. This is 3D printers. This is household OCT systems. This is automotive LiDAR, anything that need to be made in high volume for consumer level manufacturing. That scanner can be scaled in size. Bill is showing one there with a 10mm mirror on it. We use that for automotive LiDAR, that particular deliverable. I have the same ARC scanner technology here. I'm holding it up. This is a 30mm system. We've also been delivering this same architecture for up to 50mm systems recently. And this is a technology that if you have a high volume application, we can license the patent, license the intellectual property, and then you can build it at your own facility. Your contract manufacturer can build it. If you want to build, perhaps 10,000 scanners or more, and coupling that with an analog servo driver design that we can license to you, you can get the scanning portion, which is typically a cost driver of systems using galvanometer scanners. We can make that not the cost driver anymore by licensing the design, and you have it made or customized by your contract manufacturer for your application.
Yeah, so we not only manufacture laser scanners here, but we also license the design of laser scanners and also license the design of control electronics as well. And I don't know of anybody else that will do this.
So what we're showing here, new for this year, Bill was showing it earlier, our Saturn 15 scanner. This is a size compatible replacement for a legacy 6230 scanner. We're working on a 6240 replacement as well. So if you're having trouble with legacy manufacturers in terms of cost, reliability, pricing, performance, we have a nearly drop-in replacement for that. Could be driven with our Mach DSP or your existing servo driver if you already have one. The picture on the right is our ARC series of scanner. That's a 40mm mirror on that being delivered for an automotive or a LiDAR type lab application. And even with the size of the mirrors, I'm holding it up again, these are 30mm mirrors. The ones in the picture are 40, so even bigger. We were delivering 1200 hertz for the customer for doing a LiDAR type tracking application. A lot of the stuff's not posted on our website. It's kind of funny. We've got a bunch of guys really busy on design and development and manufacturing, and sometimes getting that stuff posted publicly takes a little while, but the point is we can make this stuff. Whether your beam is 3mm or 50mm, whether you need the cutting edge of performance, the fastest speeds, fastest, widest angle, most challenging waveforms, or you just need a small, cheap scanner for a high volume application, we've got you covered. We've got an entire array of options. Next slide. Okay, so another benefit of our products is if you want them, you don't have to call us, get into a long dialogue going back and forth, wait a couple weeks for delivery. We have 27 different configurations in stock with our distributor Edmund Optics. Beam sizes from the 3mm system I was showing up to 15mm. UV visible, infrared coatings. These are configured for what we'll call typical applications. It's got our mock DSP, so we deliver 4 different servo tunings for it. Likely one of them will work for your application. These things are in stock at Edmunds, so you can, buy it today, get it tomorrow, pretty much. To my knowledge, one of the fastest ways to get complete turnkey systems basically immediately. Next slide. If you need something custom, as Bill mentioned, space applications or licensing, or for whatever reason you feel like the stuff at Edmund is not applicable, you want to use your own mirrors, different coatings, custom tunings, reach out to us, get a quote, consult with the engineering team. I joke sometimes, contact@scannermax.com. It'll basically come right to me. We can get into a dialogue via Zoom, email, telephone call about what your goals are for the system. How big is your beam? How wide are you looking to scan? How fast do you want to scan? Package size requirements, electrical power consumption requirements, and we can prescribe the best solution for your application. It takes a little bit longer. There's some back and forth figuring out exactly what you need, and then we have to custom manufacture it here. It could take a couple of days to a couple of weeks to get it built, depending on how quickly you need the thing. We're able to offer volume pricing on these things as well for customers buying in moderate to high volume. We've got discount schedules, 30% or more off of list pricing for people integrating these as an OEM manufacturer into their existing laser scanning systems. And as we mentioned before, if you want to build 250,000 of these things or 20,000 of these things or whatever, we can also license the designs, license the scanner technology, and you can customize it for your package size, specifically for your application, to get the bill of material cost down, get it optimized for your high volume application.
Yeah, one thing I'd like to talk about the Edmunds systems. Edmunds stocks a lot of our systems, and so you can get it, you literally go on their website, place an order today, get it delivered tomorrow by FedEx. And this is another thing where I don't know of any other galvo manufacturer who's able to do this. But the systems that Edmunds has in stock have this generic tuning on them. It has several tunings, usually 4 separate tunings on the thing, right? So because we have no idea what the application is going to be, we put generic tunings on there, right? But what this means is that we try to by putting multiple tunes, we try to cover, well, with customers doing this, if they need high accuracy, they need this kind of speed. But what it means is it's not perfect for any specific application. So we do have customers from time to time that bought the system from Edmunds, and they say, hey, it's not quite doing what we want. And it's kind of like, yeah, well, we didn't know what you wanted. We put this generic tune in there, right? So the point is only to make, yeah, you can get it quickly, but if it doesn't do exactly what you want, or if you're a little bit disappointed on it, don't think that this is what we deliver. And that's it. That's the end of the story. Pick up the phone, call us, say, hey, we got this system from Edmunds. It's not quite doing what I want. Can you give me some advice? Can we, and oftentimes we'll give them a different tune, or tell them how to do it, or tell them how to activate a different motor, that sort of thing. So that's important, because a lot of times, we're out of the loop if you buy from Edmunds. We don't become aware that you purchased or anything else. So definitely reach out to us and let us know how the thing's working out for you. Go ahead, Brian.
Yeah, so as Bill was alluding to here, additional customizations offered from us. If you get from us directly, different sizes of mirrors, from less than 3 millimeters up to 50 millimeter beam, different coatings, custom coatings. We don't do the coating here, but we can partner with your vendor or one of our vendors to get custom mirrors made. Specific substrates. Some people really want beryllium. Some people can't use silicon. Some people only can use certain grades of optical glass. No problem, we can acquire it. Different orientations of mirror mounting. The galvos themselves, the ones we've been showing, all have the same connector, but we actually have, I think, 5 or 6 different connectors now we can offer these in, with straight or right angle connectors. So if you've got a little tight handheld device and you can't put this large connector on it, we can put a little, we call it micro match, that attaches to a ribbon cable. For any guys that know computers, like a little IDE cable that'll plug in to this thing. We can hardwire the wire directly to the galvo scanner for package size requirements. Customizations to the galvos also, if you tell us exactly what you want to do, you say, okay, I'm operating at 893 hertz with a sawtooth waveform at 83% duty cycle. Turns out that maybe our standard coil configuration is not the best for you. We can wind custom coils with special wire, special resistance, special number of turns, and build the galvo specifically for you to optimize it for your application. Output shafts, if you want to mount the mirror in a slot versus clamping the mirror on, if you know you want to change the mirror later, you know your application is going to damage mirrors, no problem, we can do all that. And then as Bill mentioned with the servo driver, you tell us exactly what you want to do. We will cook up a tuning specifically for your application instead of one of these generic tunings. Communication protocols, many people use analog input plus or minus 5, plus or minus 10 volts. We've also got digital communication protocols with different firmware versions available. Literally last night or yesterday, a customer reached out to us and said, hey, I'm using your scanners, I've been buying them direct, but we wanted to do this really special thing. We wanted to reference our serial clock instead of your serial clock, and Bill was able to cook up a custom firmware version literally that day for the customer to synchronize everything in their system to their existing clock and to their laser and to their imaging system. So we can come up with custom firmwares, custom communication protocols to do exactly what you need. Next slide. Where to learn more. Trade shows, we're at SPIE, Photonics West. Every year we've got a large presence in the Florida Photonics cluster. We'll be exhibiting at Laser World Photonics in Munich in a couple weeks. Bill and I won't be there, but we'll have one of our representatives there, and we will be on standby if you've got a question that you need answered. Just, we'll do a FaceTime or a telephone call real quick. It's a great spot to talk in person about your specific application. We can tell you exactly what we can and can't do. Can't is kind of rare, and give recommendations. Or we don't. We pride ourselves in the customer service type of thing. So there are times where we don't have a suitable product for your application, and we're happy to say, no, we don't have something that does that, but go talk to such and such at booth, whatever, and they'll get you what you need. Maybe you need a different type of encoder, or you really need a polygon scanner instead of a galvo. We're happy to point you in the right direction because, okay, we don't get a sale today, but people remember that, and they'll come back in a couple months when they do have a new project that needs galvos. And we're not just there to take your money, we're there to make sure you're successful.
We have friendly relations with our competitors too. And it was one time, just to give you an example of this, during one time during COVID, a customer contacted us and they could not get through. They literally could not get through to our competitor on the telephone. And so I knew people on the inside and had their direct numbers, and I called our competitors and said, hey, this guy's trying to get through to you. He's really kind of really needs to get something out the door here. Can you give him a call back? And so we were able to basically get him out of a supply chain crunch through our own, basically through our own contacts. Now this didn't result in any immediate money to us, but we just do it for customer service. We know we like to be friendly with people. So both the people at our competitor felt good that we were passing somebody along to them, and also the customer, they're going to remember that we were the guys that helped them to make the connection to get their product shipped. So that's how we operate here. It's not just about making the sale, it's about just trying to help out.
Where to learn some more things on our ScannerMAX website, we have a page called Can Your Scanner Do This? Next slide, Rob. Where Bill has written a handful of white papers discussing our scanner, kind of common scanner applications. People call in with a not proprietary question. Hey, can your scanner operate at 600 hertz with a sawtooth waveform and a 10mm beam? We'll create a report. There's a variety of them shown here. Showing, okay, what's required to do that? What's the heat in the galvo? What's the electrical power consumption? How many degrees of constant velocity can be delivered? How fast can we actually go? All this is kind of public facing on our website. So it'll give not just, yeah, we can do it, but yeah, we can do it. And here's all of the ancillary details about how we're going to accomplish it, the coil configuration that we might need to use, the power supply requirements. Next slide, Rob. We've also got our performance calculator on our website where you can select from our most common scanner products. You say you have a 5mm beam, you can select a Saturn 5mm or a compact 506 5mm. Select a waveform from the drop down. We've got the most common waveforms, triangle, cycloid, square, sine wave, variety of duty cycles, a sawtooth. You punch in your scan angle and it'll spit out to you what the output scan frequency will be with a variety of our standard tunings that we offer. You can also see it in a graphical form with what we'll call a 2.5 kilohertz tune versus a 5 kilohertz tune. Again, this is public facing, that reduces a lot of the back and forth of, can your scanner do this, yes or no? You just go punch in your requirements and see, okay, I can do it with a Saturn, but that's an expensive scanner. Check it out with a compact 506. Oh, I can do it with a smaller scanner too. That's going to save me some money and some package size. Again, we like to put this information out there so people can figure out exactly what they need and potentially compare to their existing systems. Next slide. As Bill mentioned before, all attendees will get a free digital copy of Bill's Laser Scanners Technology and Applications book. It's got high-level discussions of beam steering down to engineering discussions, the specific formulas used to calculate the resonant frequencies of the scanners and exactly why the mirrors are shaped the way they are. This mirror on the scanner, I don't know if it'll focus, is in kind of it's not just a basic rectangle, it's what we call a Darth mirror. It's got a strange shape to it. All the reasons of why we selected that shape, the engineering decisions behind it are covered in the book. Next slide. And then,
yeah, actually, let me just say kind of a word of conclusion here. So kind of go over what we talked about. So laser scanners are what makes lasers useful. There's several types of laser scanners. There's galvo, resonant, acousto-optic, electro-optic, MEMS, lots of different types. All of the types are mentioned in my book on laser scanners. A galvo is basically a mirror on a motor. So you think galvo scanner is a mirror on a motor. Reflecting the beam off of the mirror gives a lot of benefits. You get everything you could do with a mirror. All the great things about a mirror are great things about a galvo scanner. And so some of the bad things about a mirror is like, it will absorb, if you get the coating wrong, it can absorb the heat. It can, and plus you got to move a physical object. Those are the downsides. It's mostly upsides. Galvo scanners are compact, easy to integrate, and reasonably priced. We have both standard and generic systems available with full customization available. So this brings us to the kind of question and answer session. As you see here, you've got the contact at ScannerMAX.com here if there's some questions here that remain unasked. But nevertheless, Rob, has any questions come in?
Hi there. Yes. First of all, thank you very much for the presentation. Not only some good insight into sort of the history of galvanometers, but also sort of the various applications and sort of diverse uses that they actually have in the current market. But we do have some questions that have come in, so I'm going to try and run through those as we go and see how much time we have left at the end. The first one is, I've been using conventional galvo systems for some years. I heard you mention your servo driver is digital. Will this be difficult to implement into my system?
You want to take that, Ryan?
Sure, yeah, so I'm going to assume that by conventional systems, it'd be a legacy servo driver with a variety of pots on the edge of the board to adjust things like damping, servo gain, linearity. As you can see, our board has no pots on the end of it. Everything is tuned digitally in our software.
I happen to have a competitor system here, a bunch of pots.
So how the system operates is different. Ours is digital, DSP based, runs through a variety of algorithms. However, in terms of implementation, there's not much different for the customer. It uses typically the same power supply, plus and minus 15 volts, plus and minus 24. If you've got an existing galvo power supply in your system, it'll probably work with ours. Most people are typically using an analog input, plus or minus 5, plus or minus 10 volts. You come in directly to the board with an analog command, the same way you're doing with your traditional system. So even though our system is DSP based versus analog with op amps and things like that, from the end user side, there's typically not much difference, and they only realize the benefits, such as being able to make adjustments to their tuning in software with a built-in scope, rather than adjusting pots on the board.
Okay, so it sounds like it's not too difficult a transition from one to the other.
Most customers do not see the difference. Yeah, okay. So there's no downside, to put it that way.
Okay. We also have a question that says, can you only mount mirrors, or can you mount other types of optical devices like filters or shutters?
Yeah, so kind of just let us know what you're trying to do. we've mounted, I don't have one here, but we've mounted on our big arc scanner, something Bill has called a paddle on that scanner. It was basically a long arm with a lens at the bottom. It was about that long. It clamped onto the shaft of the scanner with a lens at the base, operating at a couple hundred hertz frequency. Recently, we've customized that big arc scanner for another customer doing a laser welding type application in the many kilowatts, and they're highly concerned for safety related applications that this thing needs to stay tight. It's never going to come off. You know, if they're operating in the tens of kilowatts and a mirror were to find its way loose, it would be a big problem for them. So we've customized the Galvo. So it's like an automotive crankshaft. It literally has a keyway on the slot to really hold this thing in place, clamped down by a couple of screws. This thing is massive, it's heavy, and we're still able to offer the performance they're requiring, you know, a couple hundred hertz on that big scanner, the one that Bill's showing, you know, the size of a fist for their laser welding application. In terms of shutters, filters, and things like that, we've got customers doing beam dumps. The point is just let us know what you need, whether you're going to supply the optic or the load, or we need to acquire and supply the optic or the load. And then it just comes down to how big is it, how quickly do you want to move it, and from there we can decide which scanner product line is the most applicable.
Okay. So we have probably two more questions here that we can probably get through, unless someone wants to add a question very quickly. So we have one here. My current or my present vendor can only work with short cables. Are there limitations on cable length?
On our system, there definitely isn't. In fact, we've got anything from teeny tiny cables that long to 6 meter, literally in stock, ready to deliver. And if a customer had received one of our mock DSP with a teeny tiny cable on it, and they just later on changed their mind and want to go with a 6 meter cable, that's possible with our system. In most cases, they won't notice the difference. There is one parameter: if we operate the servo in a way where it tries to sense the scanner temperature by resistance, all of a sudden we've added a whole lot of resistance, so the driver might think that the scanner got suddenly hot. But you could just inform the scanner driver that, oh, by the way, you've increased the cable length, and it'd be no problem. In most cases, we don't operate in that mode anyway, but in most cases, yes, you could just change the cable at will. Does not matter at all. They won't even notice a difference, and we can handle really long cables with no problem. What's the longest we've ever dealt with, Ryan? I mean, you know, some of these dental guys get into 5 and 6 meters.
Yeah, we have up to 6 meters in stock. We've got a customer doing a handheld OCT system that's making their own 10-meter cables, to my knowledge. And kind of it's not really a problem as long as you let us know so we can tune it accordingly. And you just take, if you want to make, again, that's another thing we'll offer. We will help you if you have we've got medical customers that need medical grade wire, antibacterial, antimicrobial wire, sometimes certain flammability requirements for the wire for their own purposes. And, you know, we can prescribe a cable schematic to you, which will tell you how to pin these things, how to shield these things for the best performance. And then you can have it made by your vendor if you have a specific requirement with kind of some advice from us along the way to make sure it's successful.
Okay, and we've probably got time just for one final question. My application involves heavy vibration and high temperatures. Is that something that your systems could cope with?
Definitely. Go say a few words about that, Ryan.
Yeah, that's for automotive LiDAR, that's something that we've been working on for quite a while. We've not done our own testing on shock and vibe, but our customers typically do that for their specific requirements. I think it's the ISO 16750 and IEC 668, which covers shock, vibe, temperature, salt spray, humidity, things like that. Our scanners always pass with flying colors. In terms of these things, like I said, we've got our ARC scanners optimized for automotive applications, -40 to 125 C to meet automotive temperature requirements. And then also, as Bill alluded to earlier, space applications, we've got special lubricants, or we'll call them kind of non-lubricants, that we use in the bearings for vacuum applications. And special position sensor boards, special adhesives for these zero gravity vacuum temperature extreme applications. Again, if you've got something like that, we love a challenge. If you think your application is challenging, we've got You know, Bill's got literally 40 years of experience doing this kind of stuff. So there's a good chance he's seen it or he knows somebody that does. And we could certainly find a solution, a custom solution for your application if required. That's stuff that we enjoy doing. We're happy to do. So let us know. And if we can't do it, but when someone else can, we will certainly point you in the right direction.
Excellent. Is there anything you want to add to that, William?
No, Ryan, that's a great thing about being with the company for, 11 or 12 years. It's longer than that, Ryan?
Yeah, I think it's 11 years as of last week.
Yeah, so by now he's absorbed it all, so.
Excellent, but it does sound like, you know, whether it's a custom solution or whether or not it's something off the shelf through Ebon Optics or contacting you directly, you've certainly got stock in there to make sure you can get things moving quite quickly. You know, people can contact you via the contact@scannermax.com, and you're going to be at the big show, Photonics West and Laser as well.
Right. Yeah.
Excellent. Cool. Okay, well, in that case, then I think we're probably going to have to wrap it up there. I'd like to thank all the attendees for joining us today. And as I said, this will be recorded and will be available on the optics.org website in about 24 hours. I would just like to say thank you again to William for some great insight into the Galvo's history and what you guys are doing. Ryan, thanks for your technical expertise. It's been greatly appreciated. And I look forward to seeing everyone back for a future optics.org hosted presentation in the not too distant future. So
Thanks for hosting, Rob. Appreciate it.
Yeah,
thank you, guys.